Now that you are comfortable with the basics of Git, initializing a repository, making commits, writing meaningful commit messages, and reading your commit history, it is time to take a significant step forward and understand one of the most powerful concepts in Git: branches. Branches are at the heart of how professional developers work on a daily basis. Whether you are building a feature, fixing a bug, or experimenting with a new idea, branches allow you to do all of this safely, without disrupting the main codebase. Understanding this concept is not optional. It is a fundamental skill for any developer, and especially for someone aiming to work in a team environment or in a professional project. What is a branch? To understand branches, you first need to think about what happens when you make commits in Git. Each commit is a snapshot of your project at a specific point in time. Git links each commit to the one before it, forming a chain. This chain is linear by default. Commit A, then commit B, then commit C, and so on. A branch is simply a named pointer to a specific commit in this chain. By default, when you initialize a Git repository and make your first commit, Git automatically creates a branch called main or master in older versions of Git. This branch automatically moves forward to point to the latest commit every time you make a new one. Here is a concrete illustration. Imagine your project history looks like this. Commit A, initial project structure. Commit B, add homepage HTML. Commit C, style homepage with CSS. The main branch is currently pointing to commit C. This is your stable, working version of the project. Now imagine you want to add a contact form to the website. This is a new feature that will require several commits to complete, and it might temporarily break some things while you work on it. You do not want to risk breaking the main branch for other people who might be working on the project. This is exactly where creating a new branch makes sense. Why do we use branches? Branches solve a very real problem. How do you work on something new without breaking what already works? Before branching was common practice, developers would often work directly on the main code base and overwrite each other's changes, create instability, or lose work. Branches provide a clean, structured solution. Here are the main reasons to use branches. Isolation. Each branch is an independent line of development. Changes made on one branch do not affect other branches until you explicitly decide to merge them. Parallel work. Multiple developers, or even a single developer working on multiple things, can work simultaneously on different branches without interfering with each other. Safety. You can experiment freely on a branch. If something goes wrong, you simply delete the branch and nothing is lost on the main branch. Organization. Branches give a clear structure to your work. Each branch can represent a feature, a bug fix, or an experiment, making the project history easier to understand. How a branch works in practice. Let us go back to the example above. Your project has 3 commits on the main branch. You decide to create a new branch called feature contact form to work on the contact form. At the moment of creation, this new branch is an exact copy of the current state of main. It also points to commit C, but from this point forward, any new commits you make while on the feature contact form branch will only be added to that branch. The main branch stays exactly where it is, pointing to commit C. So your project history might evolve like this. Main branch, ABC, unchanged feature contact form branch, ABCD, add contact form HTML, E, add contact form validation. Commits D and E exist only on the feature contact form branch. The main branch has no knowledge of them. This is the essence of isolation. The concept of head. Git uses a special pointer called head to know which branch you are currently working on. Head always points to the branch you have checked out, meaning the branch you are actively on. When you switch branches, head moves to point to the new branch. This is how Git knows which branch to add new commits to. For example, if you are on the main branch, head points to main. If you switch to feature contact form, head now points to feature contact form. Any new commit you make will be added to whichever branch head is currently pointing to. This is why checking out, switching to, the correct branch before starting work is important. If you forget and make commits on the wrong branch, you might end up with changes in the wrong place. Creating and switching branches. The commons. Even though this course focuses on the concept rather than a deep technical drill, it is important to know the key commands so you can connect theory to practice. To create a new branch. Git branch feature contact form. This creates the branch but does not switch to it. You are still on main. To switch to the new branch. Git checkout feature contact form. A shorter, modern way to create and switch to a new branch in a single command, git checkout B feature contact form. To see all existing branches in your repository, git branch. The branch you are currently on will be marked with an asterisk. To switch back to the main branch, git checkout main. These commands are the foundation of daily branching workflow. You will use them constantly as a developer, merging, bringing branches back together. Creating a branch is only one part of the story. At some point, the work done on a branch needs to be integrated back into the main branch. This operation is called a merge. A merge takes the changes from one branch and incorporates them into another. In our example, once the contact form is complete and tested on the feature contact form branch, you would merge it into main so that the feature becomes part of the official project. The basic command to merge feature contact form into main is 1. First, switch to the branch you want to merge into. In this case, main, git checkout main. 2. Then run the merge command, git merge feature contact form. Git will try to automatically combine the two histories. In many cases, this works without any issues. However, if both branches modified the same part of the same file in different ways, Git cannot decide on its own which version is correct. This situation is called a merge conflict, and the developer must resolve it manually. Merge conflicts are a normal part of collaborative development. They are not errors, they are just situations where Git needs human judgment. The branching workflow in a professional context. In professional development teams, branching is not just a technical habit, it is a discipline. Most teams follow a defined branching strategy to keep the codebase organized and stable. A common and widely adopted strategy is the feature branch workflow. The rules are simple. The main branch always contains stable, deployable code. No one commits directly to main, or at least, this is strongly discouraged. Every new feature, bug fix or task gets its own dedicated branch. Once the work is done and reviewed, the branch is merged into main and then often deleted. Another popular strategy used in larger teams is called Git flow, which introduces additional branches like develop, release, and hotfix branches, each with a specific role. You will encounter these concepts as you progress in your career, but understanding the feature branch workflow is the essential first step. A concrete real-world scenario. Imagine you are working on an e-commerce website as part of a small team of 3 developers. Developer 1 is working on a new product page. They create a branch called Feature Product Page. Developer 2 is fixing a bug in the payment system. They create a branch called Fix Payment Bug. Developer 3 is updating the homepage design. They create a branch called Feature Homepage Redesign. All 3 developers work simultaneously on their own branches. None of their changes interfere with the others. The main branch remains stable and deployable throughout the entire process. When Developer 2 finishes fixing the payment bug, which is urgent, they merge Fix Payment Bug into main first, so the fix goes live quickly. The other 2 developers can continue working on their branches, which are not yet ready. This is how branches enable teams to move fast without breaking things, a principle that is central to modern software development. Branches and remote repositories. So far, we have talked about branches in a local repository, but branches also exist in remote repositories, hosted on platforms like GitHub or GitLab. When you push a branch to a remote repository, other team members can see it, review the code, and collaborate on it. This is the foundation of pull requests, called merge requests in some platforms, which are requests to merge a branch into the main branch after a code review. You will explore this in detail in upcoming activities, but knowing that branches exist both locally and remotely is an important piece of the overall picture. Key takeaways. To summarize the essential points of this chapter. A branch is a named pointer to a specific commit in your project history. The default branch created when you initialize a repository is called main, or master in older configurations. Creating a branch allows you to work on something new in isolation, without affecting the rest of the project. Head is the pointer that tells Git which branch you are currently working on. Changes made on one branch do not affect other branches until a merge is performed. Merging integrates the changes from one branch into another. In professional environments, branching strategies, like the feature branch workflow, are used to keep codebases stable and organized. Branches exist both locally, on your machine, and remotely, on hosting platforms. Branches are one of the features that make Git so powerful and so widely adopted. Mastering this concept will directly impact your ability to work effectively in any development team and to manage complex projects with confidence.